Hello friends, welcome to the second video on the set of videos by Cauchy Residue Theorem. In the first video, we saw about the definition for residue, how to estimate the value of the residue at any particular pole, and the statement for our Cauchy Residue Theorem. We also found the poles and the values of the residue at the poles in the first video. This second video help you to find how to evaluate an integral using Cauchy Residue Theorem. Come on, we will get started. First, we will recollect the formulas which we learned in the first video. Cauchy residue theorem states that integral over C f of z dz is 2 pi I times sum of the residues of f of z at the poles. So, I will have to estimate the value of the residues of my function f of z, add them up at each of the poles, and then multiply it with the quantity called as 2 pi I. This is how I evaluate the integral of a given function over a closed curve called as C using Cauchy residue theorem. Now what I need is going to be the residue of the functions. The residues can be of two types. They can be a simple residue or they can be a residue for a multiple pole. If it is going to be a residue for a simple pole, then it is limit z tending to a z minus a into f of z. And for a multiple pole, you have it as limit z tending to a 1 by n minus 1 factorial d power n minus 1 by d z power n minus 1 z minus a power n into f of z. I suppose by now you must have got comfortable memorizing these two formulas on residue at a simple pole and a multiple pole. Now come on, we will move on to evaluate problems applying Cauchy residue theorem. Evaluate integral over c z square by z plus 1 into z minus 1 the whole square dz, where c is the circle. The boundaries are going to be two different quantities for me. The first case analyzes the boundary of mod z is equal to half, and the second case analyzes the boundary of mod z is equal to 2. So we will take it up one by one. The next thing or caution of word is that in the examination, if the problem is stated and without there is going to be any specification of using which particular theorem, you are at an ease to choose your choice. Like the same problem can be solved using a Cauchy integral theorem by your partial fraction method or using a Cauchy residue theorem. So you are at ease to choose your methodology. But if they have specified in the question paper that you will have to use this specific method, like evaluate using Cauchy residue theorem or evaluate using Cauchy integral theorem, please stick on to that particular methodology, otherwise we will be unnecessarily losing our marks on it. So now we are taking this under the category of Cauchy residue theorem. So all the problems which are evaluated in this set of videos will be applying Cauchy residue theorem. That's for your reference. Now getting started, we will have to evaluate the integral where c is going to be, I am going to take up with the first part called as the boundary mod z is equal to half. The very first point what we need to do when evaluation is to estimate the poles of the given function f of z. So how to estimate the poles of the given function f of z? Equate your denominator to 0. So I have this as z plus 1 into z minus 1 the whole square to be equal to 0. Z plus 1 equal to 0 gives us z is equal to minus 1. Since the power is going to be 1, you call this as a simple pole. So my point z equal to minus 1 is a simple pole. The next factor has z minus 1 the whole square to be equal to 0, which gives me z is equal to 1 how many times? Twice, because the power is 2. Hence this is going to be a multiple pole which is of order 2 to me. So the very first basic step of estimating the pole is now done. So highlight your poles. What are going to be the poles for me? Z equal to minus 1, z is equal to 1. The first one is going to be a simple pole and the second one is going to be a multiple pole of order 2. Now we will see what happens to these poles in the boundary which has been defined by mod z is equal to half. What is this mod z is equal to half? So we know that modulus is nothing but x plus iy. This is going to be equal to half modulus of z. So what to do to remove this modulus? This is nothing but root over real part square plus imaginary part square is equal to half. If to remove the square root, square on both sides. So we have x square plus y square is equal to half the whole square. Can you identify this equation? Yes, you are right. This represents a circle with center to be equal to 0, 0 and radius to be equal to half units, because we know the basic equation for a circle is x square plus y square equal to r square. So this represents a circle with center 0, 0 and radius equal to half units. The second step for the problem is to draw your boundary. So let us sketch the boundary. Circle with center 0, 0 and radius to be equal to half units. Let us draw this circle. After drawing the circle, step number 3. So step number 1, what did we do? We found out what is going to be the poles. Step number 2, we found out what is going to be the boundary and we sketched it. And step number 3, we are going to see what is the role of the poles over here. What is the poles for me here? Z is equal to -1 and Z is equal to +1. Now this can be identified as the complex number -1 plus I times of 0 with no imaginary part, and this can be identified as the number 1 plus I0 as the imaginary part. Hence the coordinate x, y makes it as -1, 0 for the pole Z is equal to -1, and this makes it as 1, 0 for the pole Z is equal to 1. Now let us plot the poles in my diagram. Where is my point -1, 0? My -1, 0 lies over here. It is here in this portion. And where is going to be my pole 1, 0? 1, 0 is going to lie over here. What do we observe from this diagram is that this is going to be my boundary, which is called as C, and both my poles, which is Z is equal to -1 and Z is equal to 1, lie outside the value or outside the boundary mod Z is equal to half. Both the poles lie outside the boundary mod Z is equal to half. What will happen to the value of the integral for the quantities of the poles that lie outside our boundary? Yes, you are right. The value vanishes when the poles lie outside. So when the quantities are going to be outside, the value of the integral is going to be 0. Hence, by Cauchy residue theorem, what happens is integral over C, the function what we had over here, which is z square by z square divided by, let me make it as z square divided by z plus 1 into z minus 1 the whole square, z plus 1 into z minus 1 the whole square dz will take the value 0, because 2 pi I times the residue at the first pole is going to be 0, the residue at the second pole is also 0, so it is totally going to be 0. So this completes the first portion of our problem for the boundary mod Z is equal to half. Now we are ready to find the same evaluation but with a different boundary. What is going to be the second boundary for me? Mod Z is equal to 2. Come on, now we will explore on mod Z is equal to 2. What is mod Z is equal to 2? X plus IY equal to 2. So it is x square plus y square the whole square equal to 2. So I have x square plus y square is equal to 2 square. This represents a circle with center 0, 0 and radius to be equal to 2 units, which we have now plotted over here in the diagram. Now getting back to my poles. What are my poles? Z is equal to +1 and Z is equal to -1, which I had to be equal to 1, 0 and -1, 0. Let me plot the poles for my Z is equal to 1, 0. Where is my point 1, 0? Here is my point 1, 0. Where is the point -1, 0? Here is my point -1, 0. What do you think is going to be the nature of the poles? Are they lying inside or outside? Yes, you are right. Both the poles lie inside our given boundary. Therefore, evaluation of the integral is not going to vanish, and it is exist and it is possible. So what is our next move? Our next move is to evaluate the residue at the poles, which is going to be z is equal to +1 and z is equal to -1. After evaluating the residue, what we will have to do? We will have to add the residue 1. Let me keep this as residue 1 and this is residue 2 and residue 2. After adding the residue 1 and residue 2, you will have to multiply it by 2 pi I, and this gives you the value of the integral f of z dz. So this is going to be our roadmap. So we are going to estimate the two residues at the poles, add them, multiply them with 2 pi I. Let's get started with the first residue, which is going to be simple pole. Which is the simple pole? Z is equal to -1. So let me estimate what is going to be the residue at the simple pole z is equal to -1. Copy paste your function f of z. What is your function f of z? The function f of z is going to be z square by z plus 1 into z minus 1 the whole square. So it is going to be z square by z plus 1 into z minus 1 the whole square. So the next thing we will need to is going to recollect the formula for the residue. So recollect your formula. At the simple pole, we have the value of the residue to be given by limit z tending to a, z minus a into f of z. So now we are estimating the limit at the residue z tending to -1. So it is z minus of -1, so makes it as +1 into f of z. So this makes it as z plus 1 into copy paste your function f of z, z square divided by z plus 1 into z minus 1 the whole square. Now allow your limit z tends to the value -1. Automatically the pole will get cancelled off, leaving you with the remaining function. Wherever you have z, replace it with the quantity -1. So you have this as -1 the whole square divided by -1 the whole square after applying the limit. -1 the whole square makes it as 1 divided by 1 minus 1 minus 2 the whole square. It's going to be 2 square and 2 square makes it as 4. So the value of the residue at the simple pole z is equal to -1 is given as 1 by 4. The next part which we need to do is estimate the residue at the multiple pole z is equal to 1 of order to be equal to 2. Once again, copy paste your function f of z, which is given by z square divided by z plus 1 into z minus 1 the whole square. Now it's time to recollect the formula for the multiple pole, and it is given by limit z tending to a 1 by n minus 1 factorial d power n minus 1 by dz power n minus 1 z minus a power n into f of z. Now copy paste your functions over here. So this is going to be equal to limit z tending to the value is going to be 1, order is going to be 2, which means n is equal to 2. So I have it to be 1 divided by 2 minus 1 factorial d power 2 minus 1 is going to be 1 divided by d z power 1 z minus 1 the whole to the power of 2 into your f of z. So we will apply limit z tending to 1. This 1 by 2 minus 1 factorial is 1 by 1 factorial. 1 factorial is going to be 1. So I have d by dz of z minus 1 the whole square. Copy paste your function f of z. So z square divided by z plus 1 into z minus 1 the whole square. We see that automatically the poles gets cancelled off over here, leaving with just the function z square by z plus 1 to be differentiable over here. So we will have to differentiate the function z square by z plus 1 and then allow limit z tending to the value called as 1. So first we will go on with the derivative. Differentiation of u by v is v square v du minus u dv. So I have this as z plus 1 the whole square. Keep your z plus 1 as such. Z square on differentiation is going to be 2z minus, keep your z square as such, z plus 1 on differentiation is 1 plus 0. So this is going to be my derivative. Now allow limit z tending to 1 in this quantity. I will have 1 plus 1 into 2 times of 1 minus z square is going to be 1 into 1 divided by 1 plus 1 the whole square. So 1 plus 1 is 2, 2 into 2 makes it as 4, 4 minus 1 divided by 1 plus 1 is 2, 2 square makes it as 4. So I have 4 minus 1 which is going to be 3 divided by 4. So the value of the residue at the second point is going to be equal to 3 by 4. So now having estimated the value of both the poles, now the task of estimating both the residues have been over. So we move on to check what is the next step. Residue 1, residue 2 is over. So I have to add up the residue and then multiply by 2 pi I to get the value of the integral. So let us move on to the last stage. So the value of the integral, integral from z square by z plus 1 into z minus 1 the whole square dz is 2 pi I times residue 1 plus residue 2. So it is 2 pi I times the value of the residue 1 which we obtained for the simple pole was 1 by 4 and the value of the residue for the multiple pole was 3 by 4. So it is 1 by 4 plus 3 by 4. So 4 LCM 4. So that makes it as 1. So the value is going to be 1 into 2 pi I. So the final value of the integral is going to be 2 pi I. So quickly recollect the steps. So what we need to do is just first figure out your poles. After figuring out the poles, go on to fix your boundaries. Check whether the points or the poles lie inside or outside the boundary. If it lies outside, the value of the integral is 0. If it lies inside, then you will have to estimate it depending on whether it is a simple or multiple pole. Then after estimating the value for a simple pole or a multiple pole, add the total residues and then multiply by 2 pi I to get the final value for your integration. Thank you.